live. I'm just waiting for a little confirmation. Quickly, very, very quickly. And okay, I can't tell if we're live. I'm gonna hope that we are. All right, we're going for it. What's going on, guys? Reese here, DevRel at VeChain, and I feel like my camera's moved, so I need to sit over here this week. So this is the second workshop that we've done as part of the lead up to the hackathon, right? So this one specifically is about like backend development, so we're going to be using the VeChain SDK. And I'm going to cover everything in kind of a couple of minutes and just making sure everything's working properly, because you know what these things are like, something always goes wrong. So trying to actually get it up on my other screen here, but it doesn't seem to want to. Okay. Well, hopefully we're live. Let me just message someone and double make sure. Okay. Get rid of that. And okay. Cool. Now I can turn that off. Right. So, like I said, this workshop we're going to be covering kind of backend development, SDK, using the SDK to interact with the chain. And there is a ton to go through over the next 2 hours. So grab yourself a coffee or a glass of water. I had some problems last week, so I got a whole jug with me this week. Hopefully we won't have a repeat where we had a coughing fit about halfway through. Apologies in advance if that happens. We are a little bit more prepared today to share some code with you, so that while you're watching along, you can actually access the code. We can run through examples and stuff together, and I think that's really, really important. So what I'm going to do is I'm just going to share that with you now, if I can find it. And let's go back. Here we go. And oh, actually, I don't know if I'm going to be able to. Oh no. Wait, maybe I can fix it. I'm going to pop it in the description, because I can actually do that, I think. Let's stick it at the top. Code base. All right, I haven't done anything exciting with the title or anything, or formatting. Apologies for that. Okay, cool. So now we got that done. Hope everyone's well. I know we're starting a little bit late. Apologies for that. But what I'm going to do is I'm going to switch screen, and then we can dive into it. So what do we have? Okay, turn off my notifications. Right. So, exciting stuff. Actually, you know what? I'm just going to hide me for the moment, because you don't really need to see me too much. Okay, so this is, like I've already mentioned, this is these workshops. We're doing a series of 6 of them leading up to the hackathon, which is going to be happening on the 22nd of September. It's going to be starting, finishing on the 6th of October. So there's a 2-week period for you to basically submit or start and submit projects. We're going to take the next kind of 10-15 minutes to go through a bit of that information, and then we're going to look at examples, code, how to do things using the SDK, so that you guys can basically learn the tooling that you can use to implement solutions for the hackathon. The code base should be available. There should be a GitHub repo in the description. If there isn't, I'm sorry. I've tried to update it, and I don't know why, but I can't pull up the live stream. So I can't actually check that it's there, but it should be there. Anyway, so like I've already mentioned, my name's Reese. I'm dev at VeChain, and I'm going to try and keep my mouse out of the way so you can actually see stuff. And okay, so first things first, workshop plan. So there are a few things that we're going to cover. First, we're going to have a little look at the SDK itself, the kind of things that you have available to you, the kind of things we can do with it, what you might want to use it for, what it's not necessarily so good for. We're going to look at reading, writing, and listening to events on chain. So these are the main kind of functions that you can use, or the main kind of actions you can take to interact with the blockchain, right? You can read things, read changes, read blocks, read transactions to get information. We can write, obviously signing transactions and submitting them to the chain to make changes. And listening to events is basically setting up like a connection to a smart contract, to transaction types, to specific assets, to blocks, even any kind of programs or addresses or accounts or anything that might be existing on the blockchain or actions that are being taken. We can listen for them to then act based on those kinds of interactions. Now, that's kind of a very like high level view of the kind of things you can do, but in the example we're going to be looking at, we're going to be basically subscribing to blocks. Super simple, so that we can see what happens. So we have regular events for a start. We can see the interactions with the chain and how we can handle that data when it's given to us using WebSockets. Then we have a look at clauses. So clauses are a special kind of feature in VeChain, which allow us to basically send assets, interact with smart contracts, etc. So we're going to take a nice little look at that using the example smart contract that we had in the last workshop on Solidity. And we're going to have a look at fee delegation as well, which is like, again, another one of those features of VeChain that make it really, really nice to use. And yeah, great user experience as well. But we'll explain more about that if you don't already know. So about the hackathon. The hackathon, as I've already mentioned, 22nd of September to the 6th of October. Builders will create EVM smart contracts on Solidity to build decentralized applications. I'm just going to call them dApps from now on, but decentralized applications that address real-world challenges with a key goal of mass adoption for users. It's not just mass adoption of users, though. It's really, really focused on the sustainable development goals of VeChain. So one thing that VeChain is really, really active in pursuing is a deep focus on sustainability and basically validation of that kind of stuff to prove that something is working towards the betterment of society, the community, and the world. All right, I've already been talking too much, so I'm going to need a quick drink break. Quick little swig. So yeah, there's a big push for sustainability goals. This is the forefront of what we're going to be looking at for the hackathon. So hackathon prize, obviously it's a hackathon, there is a prize pool. We have 3 different tracks that we're going to be, that you can submit projects under as part of this hackathon. And there is a total prize pool, obviously split between these tracks, of 30K, which can be distributed in either VET or in fiat, depending on the preferences of the people who are, successful in earning those rewards. Eligibility criteria, you can see here we've got innovation and creativity, technical skills, impact and feasibility, and business model and research. And actually, as a little side note, there is also an extra little bonus prize pool for tooling feedback. So we're really looking for, as part of this, some feedback for help improve the tooling for the community as well, to make it easier to build on-chain in the future. Okay, focus areas. So like I have already mentioned, there are 3 tracks. There are a total of 17 Sustainable Development Goals, or SDGs, which I'll refer to as D, not T, by the way. You might have just, I'm not sure if I misspoke or if it just sounded funny coming out of my mouth. But 17 Sustainable Development Goals that are really, really, as it says here, heavily embedded in VeChain's values. We're looking for people to, or teams, small teams, to develop functional prototypes in one of the following 3 areas, utilizing VeChain's tech stack, and deploy smart contracts on VeChain Thor, which is the name of the blockchain, VeChain Thor. So if we start talking about VeChain Thor later and you're not familiar with the VeChain ecosystem, that's what we're referring to. The goal for all apps in VBeta is to leverage the token incentives to promote positive behaviors. And we can go into that in a little bit more detail, but I think that generally speaking, if you just go to VBeta and check out some of the apps, it'll give you a really good understanding of the kind of things we're looking at. But these 3 different tracks will probably push you in the right direction to start thinking about the kind of things you can build. So the first track is social impact, which is building for people. We've got 3 SDGs in here, four, sorry. No poverty, zero hunger, clean water and sanitation, gender equality, and there's actually 5, reduced inequalities, as like a general statement. The next one is economic and environmental impact, protecting our planet, obviously. Looking at life below water, decent work and economic growth, industry, innovation, and infrastructure, specifically towards sustainability, protecting the environment. Then the last one is ecosystem and technical innovation. This is for growth of the VeChain ecosystem specifically, working at infrastructure and tooling, cross-chain apps using one chain, who will be running a workshop later in this series, by the way, so definitely stick around or subscribe to check that out. And we're looking at account abstraction and sustainability aligned games. That is a little bit of a tongue twister. So these slides, we'll make these slides available, all right, guys, because I'm gonna spend ages talking through these things, and it might just be good to have these as a reference. But track 1 in a little bit more detail: fight poverty, hunger, and inequality, build transparent aid systems, equitable microfinance, or clean water access tools. Now, these are very broad suggestions. If you're building something towards these goals, you can submit it under this track. You're not limited to fighting poverty specifically, you know, but if we're working towards these goals, then that's the kind of thing that we're looking for. Track 2, in a bit more detail, boost the sustainable growth, preserve life below water, and innovate responsibly. We're thinking fair trade marketplaces, tamper-proof ocean data, or green industry infrastructure. And the last one, as I just mentioned, infrastructure and tooling, cross-chain apps with a one-chain bridge APIs, account abstraction tools, or games with a sustainability twist. A little zesty twist of sustainability in there, guys. Okay, we also have like quite a few, several different grant options as well, and the VeChain grant program supports developers building sustainability-focused X-to-earn dApps. X to earn is like something to earn, all right? It's not, yeah, that's like a placeholder X. X to earn dApps, tools, and infrastructure. The first time I read it, I was like, X to earn? Like, what are we even talking about? That's why I thought I'd provide that clarification for you guys. So we got app grants of up to 30K. We've got tooling grants of 50K. And these are designed to help support builders in the ecosystem and help get them off their feet and deploy tools to the community and to people in general as well, because of a lot of the tooling and the apps that are built, particularly for VBeta, are user focused, particularly users who aren't necessarily familiar with crypto in general. So it's not like crypto native tooling or applications for VBeta. Definitely go check out VBeta. All right, cool. So we've covered all that. Now we can get started. This is my cue to get started, guys, in case you were wondering. I'm going to pull myself back up now so you can see me. Yeah, so now we're going to have a little look at some of the SDK tooling. We're going to introduce the SDK and the kinds of things that we have available to us. And we're going to have a look at some examples of the kind of things that you can do, ways you can interact with the chain, and we're just going to dive straight in. So, oh, I'm going to actually have a little drink. I need to fill up the glass. I had a little bit left from earlier. So the SDK Essentials. Nice. I'm just going to pop that there right in the way. So SDK Essentials. what is the SDK for? Well, an SDK obviously is a software development kit. And the purpose of it is to provide tooling or some level of abstraction to make it easy for you to interact with a particular protocol or something else, right? So in this specifically, we're looking at VeChain, obviously. So we're looking at connecting to VeChain Thor, which is the name of VeChain's blockchain, interacting with the chain, so being able to either write information or react to information that's either put on chain or that's read from the chain, and handling block data as well. So there's so much blockchain data available and there are so many ways that you can categorize it. The SDK makes it really, really easy to be able to handle those kinds of things. So we're looking at blocks, transactions, addresses, assets, and there is more as well. Like I already mentioned, we're going to be having a look at some smart contract clauses today. And clauses, as I said before, are a really neat feature of VeChain that allow you to basically make smart contract interaction a little bit more flexible and give you a lot more options in how many transactions you need to make to be able to interact with those kinds of tools. Okay, so the main thing are these are the three main actions that you can take with the SDK or interacting with the blockchain in general. So when you're interacting with the blockchain, it requires a direct connection to the chain, and some chains handle that by requiring you to like operate a node or pay for some like API service or endpoint of some kind. With VeChain, we don't need to do that. We have a specific tool or a class called Thor Client, and we use Thor Client to be able to connect to the blockchain through public nodes to be able to query data, submit transactions, and establish connections to be able to listen to events. So here we've got some information about that. Interacting with the blockchain requires direct connection, as I've already mentioned. And in some cases, specifically when we're writing, it requires gas or fees, right? Transaction fees to be able to take certain actions. Read-in data is kind of the easiest one, which is the one we're going to look at first, which is a one-off request, like an API call for certain information. There's no gas required, no wallet. We just need to establish that connection and ask for the right information and then handle it in some way, which again, we will be looking at. Listening to changes is generally handled with a subscription event. So in this case, we're going to be looking at WebSockets. It's waiting or establishing a connection to listen to specific events on chain. You need to obviously predefine them. And no gas is required for this. This is just basically long-term listening. Sorry, long-term reading, right? It's waiting for specific events. And then obviously handling them and reacting to them as necessary for your business logic. And the last one is writing data. Writing data is kind of self-explanatory, I think, based on the other two. It's here publishing and distributing information to the network. It requires gas fees. It generally requires a wallet. And yeah, you're going to need to be signing actions because changing things on the blockchain costs money, right? Writing or gas. I shouldn't really say money. There is a gas or a fee associated with it, which is paid in VeThor, which is the gas token on VeChain. Because VeChain uses a dual token model, 2 tokens. One is VET, which is the asset, the native asset, and then VeThor is the gas or the fee currency, essentially, the token. I probably butchered that explanation, and apologies, but I'm live streaming, all right? The pressure's on. You understand. So read-in data, this is what we're going to be looking at first. And as I mentioned before, it requires this connection to VeChain's mainnet or testnet. It requires a connection to the blockchain. Here we've got VeChain's mainnet where we import our Thor client from VeChain SDK network and we connect to it with thorclient.at and the mainnet.vchain.org URL, which is the way that we connect to the mainnet. In fact, I'm actually just going to get out of here now. Because we can just be looking at examples. Oh no, I'm stuck. How do we get out? There we go, figured it. All right, I'm gonna get rid of that. What are we looking at? I think we're over here, yes. All right, get rid of that. So I'm gonna need to zoom a lot, aren't I? I remember from the other day. First off, let's just kind of pull this up a little bit and then get rid of it. I think I'm just going to quit using the mouse. because mice. Cool. Mice aren't very good. All right, so let's zoom in a lot. Let's get rid of all of these pages for you. And we'll just have a quick look at reading. So actually, you know what, before we do that, let's just have a look at what I have here, because this repo, there's a ton of stuff. I've done it in JavaScript, so it's just super easy to look at and kind of understand. Generally, when you're writing apps, you're probably going to be using TypeScript. That's fine. But I haven't, just because JavaScript's just, it's just easy to work with, isn't it? And as long as things behave as they're supposed to, it's not too much of a problem. So in this repo, I've got a source file because I'm used to working in TypeScript and everything lives in there. We have, ignore the node modules because that doesn't matter. If we have a look at our packages, we have in here two VeChain specific dependencies for the SDK, but there are actually 5 or 6 packages that are available as part of the SDK. There's also errors. I'm going to actually pull it up so I don't tell you the wrong thing, and we'll just go packages. So we have there's 7 packages or 8 packages, apologies. So we've got core and network. These are the ones you're going to be using most of the time. Then there are other specific packages to handle certain things. So there's the hard hat plugin, which we'll look at in a second. There's the ethers adapters. There's a KMS adapter for AWS. There's RPC proxy, logging, and errors as well. So there's a bunch of different tools. Currently, they're in several different packages on NPM. Most of the time, you're going to need SDK core and SDK network. So the first thing that you would do is install these. If you're using this GitHub repo, you don't need to worry about installing them directly because they're already in the package JSON. So you just need to run npm install and it will install them for you. I'm assuming that most people who are taking this course actually have done some programming before, but I'm still going to explain it to you as if you hadn't, all right, just in case. So I also have this file here called learn to earn JSON, and this is because I compiled what we didn't do in the last one, which was in the Solidity workshop, was a huge mistake, because we didn't actually deploy the contract. I didn't realize until like the next day that I hadn't done it. And it's like a fundamental thing that we should have done. So what we're going to do quickly is just have a little look at that. And in here, we have, this is using the hard hat plugin. So if you run, let me just, it's npm create vchain -dap. It gives you a couple, it's basically like a script for initializing a repo or a project. And it gives you the option to use a hard hat plugin that's already basically tailored to VeChain. And so I used that. I added our learn to earn sol in here. And in here you have a couple of scripts, including deploy, which you can use to deploy the contract. Now, because the contract has a constructor with an address, you have to do it with that address, and that becomes sorry, the institute address. I'm such an idiot. Oh yeah, it has the pool contract. That was the address that we needed, which you can get on GitHub. I haven't got the link for that to hand, so I'll have to get that to you separately after the fact. But essentially, you need to have the X2N contract to be able to deploy it. So what I recommend you do instead is not really worry about that right now. As I said, in this repo, I've already included this compile code. I've already paid to deploy this contract to the testnet so that you don't have to worry about it. And in here, if you remember the Solidity workshop, we have our ABI here as well. So again, we don't need to worry too much. All the code should run just straight out the box for us. So it shouldn't be anything that we need to worry about too much. Everything should just work because I've obviously written it all in advance for you guys. But basically, that's what this learn to earn.json is. It's the contract code, the compiled and deployed contract code. Cool. So back to our source. Index.js, I think, just has printing blocks. Yeah, we'll look at that in a second. Don't worry too much. But there is a ton of a ton of different kind of modules in here because I've set it up for everything to just run as scripts. And what I mean by that is we'll say node src, I don't know, read blocks. Is it read blocks? Let's find one. Well, let's just run index. Yes, and then it will print out a block. All right, so things should just execute perfectly for you. It shouldn't be any issue. You can just run a specific file or src subscribe, for example, with Node. So it's just really, really easy to run for you guys to test as we go along with this code. And you know what? Actually, I'm gonna, because that printing, I'm zoomed in too much for it to be able to print things, aren't I? Swig the old gamer juice. So yeah, I mean, let's get rid of that now, because otherwise we're going to be distracting ourselves. And now we can actually have a look at some of this info, right? So sorry about that quick tour. What I have in this project, actually, as you can see, when I print stuff out, I have some functions in here like printing, mapping blocks, and this lines function, color scheme and colors, and chars here. And essentially all this is doing, this is just handling the data and like formatting it in a way that makes it look kind of nice. So I've got these silly little QR things that run, which obviously you just saw, but I'm going to pull it up again, which basically takes the data, it organizes it a little bit. We'll have a look at it properly in a second. But I've just done that so that there's some visual feedback and it's not just some like boring JSON object. Some of the stuff that we return will be a boring JSON object, but I've tried my best to make it a little bit more interesting to look at. All right. So now we can get rid of that. Right. So I was just mentioning before we did the whole tangent about reading blocks. So there are several different kinds. Well, there are two main functions basically for reading blocks. And we're going to use reading blocks because it's kind of the simplest one to start off with when we're looking at like reading data from the chain, because you don't need any specific information other than maybe a block ID or a number to be able to pull that data from the chain or to query it. So in here, we're importing our Thor client, which is what was happening in the slideshow, if you remember that just a second ago with the non-syntax highlighted code. So yeah, we're getting that. Thor client is, oh my god, that thing's going to be really annoying. Back to the keyboard. So Thor client is a class that we import from the network, SDK network package, and we use that to connect to the chain. In this one, you can see I'm connecting to testnet.vchain.org, but if I wanted to connect to mainnet, I just put mainnet.vchain.org instead, and then ignore all these comments. We're just going to go pull that, and this will bring block number 123.45678 from mainnet. And then if I go up here, and oh no, that was testnet because I forgot to save it. If I go up here and run it again, we'll get the mainnet block 123.45678. Okay, so there, the color schemes adapt. All right, I've just got a silly little program that does some maths. We can change that in a bit if you're interested. So right now I've got Genesis block, but what I wanted to do, let's get rid of that first. So there are two main ways that we can return block data from the chain. There's get block compressed, and if we go over here, there's also get block expanded. And so we're just gonna rename these so that they actually represent the information that we're getting. So there we go. All right, so now when we just run it like this, it should fail because we're not actually, oh yeah, I'm using cursor. I can like Alt tab, right guys, don't just tab if you're using like AI, just use Alt tab. It's so much better because you can specify things. So here, I forgot to save again, didn't I? I feel like that's gonna happen a lot today. So if you can see here, I don't put any argument in with that method. It doesn't return anything. It just errors. It's a bad request. And that's because I didn't put a block number or an ID. And that's what both of these functions require. I know I'm only, let's just do the other one. Print expanded, cool. And that should just print them automatically, okay. I don't know what this is all doing, so we're just gonna get rid of it. Don't need that. Don't need that. Don't need that. Cool. So we don't have an argument for either of these methods, and actually both of them need arguments. And what they require, it's not going to pull it up, but it's either an ID, so like a block ID, which will be hex encoded, or it'll be a number, like the block number. So previously I did 1, 2, 3, 4, 5, 6, 7, 8, but for we can just do 1, and we can just do 1, and then we can print them. And get block compressed and get block expanded return two different kinds of information. Compressed returns basic block data plus a list of transactions, and get block expanded returns a much more detailed look at those transactions. And actually maybe that's not the best one to look at, but if we went back to 1, 2, 3, 4, 5, 6, 7, 8, and can't type, and we'll stick with mainnet actually, because generally more transactions happen on mainnet. We can clear this, we can node, what was it, index.js, and you'll see here we've got two different blocks printed out. I should have specified. I should have specified, why didn't I do that? Oh, let's get rid of this. So when we use a get block expanded and get block compressed, because I'm handling this with the pretty print kind of extra function, it's not going to print them out just as you would see. Instead, I've already kind of organized that data. So I'm going to do that. We're going to console log, and wait, you're going to give me the next one as well? Yes, yes it is. So here, this is going to be ugly now, guys. And when we run it, we're going to get two lines of, or two JSON objects returned. The first one is our compressed block, which you can see has these 3 transactions here down at the bottom. In a list, it's just the transaction IDs that are returned. And then in the next one, it's the same block, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And we get an expanded look at those transactions as well. So instead of just the transaction ID here, it actually pulls a lot more information. So we can look at things like the origin, gas payer, the amount of gas each transaction used, and just a bunch more information for each of the transactions. Now, obviously, if there isn't any transactions, it'll just be an empty list. But assuming that there is, it'll give you a lot more information. We also get some other things in get block expanded that we don't get in get block compressed. And one of those things is finalized. And another one is, well, let's see. Oh no, is finalized is there? What's the other thing we don't get? Maybe they are the same. Maybe they were the same all along. TX root, features, no. I thought there was something else missing, but maybe I'm mistaken on that. All right, guys. Well, if you find something, put it in the chat. Oh, silly old sausage. Okay, so that is a really boring JSON object. It's not that exciting. But what we can do is instead of just having this stuff where we call a specific block, there are other functions that we can do based on this, and that's with using like specific keywords that are identifying special blocks. So the first one is best. So getting best block compressed will return, well, we'll have a look at them. We'll have a look at them. So there's Genesis, which is the initial block of the chain, the block that initializes the blockchain. And that's just, we get that by, instead of putting something in here, we'll go over here and we'll just put 0, because you can think of like a blockchain as almost like a linked list, right, of blocks, right, which is a history of transactions. And so 0, index 0 of that list would be our Genesis block, the initial block. And so just putting the 0 as the block number that we're querying will pull the Genesis block, and we don't need to worry about it. It's not that exciting. But we have best block, and we have another one, if I can get around, which is final, I think. We'll see. We'll see soon enough whether or not I got it right. Okay, I didn't get an error, so that's positive. So getting best block, well, let's have a little look. Let's have a look at what we've returned. Oh, we got a ton ton of transactions here. So getting our best block, the block number is 225.09183. And if we go down here, we got 225.08820. So best block, what best block is essentially is the last finalized block, and final block is the latest accepted block, because there's a difference. There's a difference between blocks that have been committed to the chain and blocks that have been finalized. There's a chance that you can roll back a certain amount of blocks, and until that point, basically, even if stuff's rolled to the chain, if there is a fork or if there's some contest between different blocks, things can change, things can get rolled back and returned. So basically, it's to handle those differences. And you can actually see here, retrieves details of the finalized block, and best is the latest block. All right, I forgot about that. I forgot about the old hovering. Okay, so a very, very high level look. We're mostly, when we're reading, we'll probably look at mainnet examples, but when we start writing to the chain, we're going to switch over to testnet. All right, guys, just let you know about that. Because there's more data to read on mainnet, but we're not going to be actually using proper assets or proper vet and vthor whilst we're doing this example. Right, so there's a couple of other things that we can have a look at. But one key thing, which isn't really about reading data, is actually generating wallets. And this, we can read, actually, you know what, let's do transactions first. So if we have a look at transactions, and you know what, I need to do source. We'll actually have a look at this first. So we can read transactions as well. We can read addresses. We can read to find like different kinds of values, like what kind of assets they have and stuff like that. It's not always needed. Obviously, these are all kind of very simple functions that you would call on the blockchain. But get transaction here, we have an example. This requires a transaction ID. And the reason we started with blocks is because we don't need to know this information in advance. But for example, what we could do is grab one of these transaction IDs and put it in here if we're querying mainnet. So actually, let's do that. We'll switch to mainnet here. We'll pull this up. Should never have shortened it. So we'll go up here and we'll just grab this one. I know we already have the details, but we just want to do delete. And so what we're doing is we're using our Thor client. So we're generating our Thor client, connecting to mainnet, and then we're basically awaiting Thor.transactions.getTransaction. GetTransaction is the method of our transactions class or function that allows us to pull data about transactions. If we have a look at, I don't know what the shortcut is to move around cursor because I don't really use it. If we have a look at blocks, to call our block querying functions, we're using this blocks. All right, and so that's basically just telling us which module that we're using specifically in our Thor client to be able to access these methods. Transactions is obviously transactions. It's very intuitive. So if you think, oh, I'm trying to access blocks, you use blocks. If I'm trying to access contracts, what would I use? Contracts, that's it. Well done, guys. I knew you had it. I knew you had it. All right, so anyway, we use this await Thor.transaction.getTransaction. We add our actual transaction in here, our transaction ID, and then we can basically query that data. What I do with that, you can see it, I just handle it in some way. If I just get rid of all of this and just console log transaction, actually, let's do a side by side. We'll put it down here, console log tx, and then we'll, why doesn't it just let me shuffle it? We'll just put that up there, Command S. Transactions it's called, isn't it? Thanks, guys. No, it's not called transactions. Oh, wait, it is, but it's source. No, it's not. What is it called? What is it called, guys? Have I just misspelled it? I can't find it. Yeah, I've just misspelled it. Of course I have. Nailed it. Okay, so here we go. Now, in here we've got our kind of handled, our data handled version of our of our transaction, sorry, where it has basically just taking the information from our return JSON object from our transaction, and then it's pulled certain bits of data. I've just done everything on an individual line to make it easy for you to read and kind of understand. And then I've added it to a list and done the little printing stuff. All right, don't worry too much about that. That's just making it look good for your viewing pleasure. But essentially what actually comes out of this is this JSON object. And there's a ton of information in here: transaction ID, transaction type, block reference, an expiration, which is like a time period it needs to be accepted into a block, clauses that have been called, which are transaction functions essentially, and the amount of gas used, max fee per gas, max priority fee, the origin, delegator in case the transaction fee is delegated, and we've got our nonce, we've got the size, we've got some metadata. And the metadata has block specific information. Now, we don't need all of this data necessarily, and we wouldn't need it all the time. So being able to just know the kind of information you're looking for and handle it is obviously a much easier way to be able to deal with this stuff. But just know that I'm going to be showing stuff that basically looks like this in different colors. And in reality, you'll return this huge JSON object with all kinds of information. So I'd encourage you actually after this or during to have a little look at these kinds of things, have a look at them as kind of a raw JSON object, and have a look at what we've done to handle that data and print it in a specific way. Cool. So that's transactions. There is a ton of things. I have no idea what the time is, by the way, guys. I'm just kind of rambling at this point about reading. Okay, it's 1:45. We got loads of time. This is just a very simple look at reading. All right, we're going to kind of move away from reading. Now, actually, you know what? We're going to move away from reading in one more example. And in this one, we're going to have a look at two examples. Yeah, two examples. Off to a great start. So the first one is returning a balance. And assets, or the balance of assets in when you query them in VeChain, will come back as hex. And what hex encoded big int, sorry. And so when you're querying data, like you want to query at the account balance of a certain address, so in this case we've got an address here that we're querying off the testnet, we use for.accounts with a getAccount function, and then we just pass that hex string into it. And then what we need to do with that data, we need to, well, let's have a look. Let's have a little look at it otherwise. If we just say cons, get rid of that. Let's have a look at it. Let's have a look at it raw. So I think return balance is a much more kind of, actually reading transactions can be really useful. Like if you're trying to look at something, trying to figure out why something failed or where it's gone, if there's a random transaction that you want to inspect, then it is really useful. But I feel like looking at balances of accounts is going to be something that's done a lot more normally, like a more common function. So it's a good example. But if you see how this returns, let's stop distracting ourselves, shall we? We have an object with balance and energy. Balance is the VET balance, and energy is the VeThor balance. And remember, that's used for paying gas. And then we have this other bit of information here called hasCode, which is false because this isn't a contract. If hasCode returns true, then you know that you're querying a smart contract address. All right, just in case that was something you were looking at. And you can see here the kind of handled version, which has kind of been sanitized a little bit. Our VET balance is 11885, and VeThor is 20517. And what we've done here is we've just converted it from hex into a big int, and then we've divided it by 10 to the power of 18, because both of these assets have 18 decimal places. So we're just getting rid of all of that. If we didn't, and we just said that, I mean, we can kind of imagine what's going to happen, right? We're going to just have a ton of zeros at the end. So it's just to make it more of a human readable value for you. Cool. Return imbalance. And then the other thing that we kind of wanted to have a look at as well for reading is historical data. So no, we should probably look at contracts first. I'm going to come back to that. So when we're reading a contract, by the way, guys, I still can't pull up this live stream. So sorry about that. So if you have any questions or anything, I don't really know how to get them to you. Hopefully one of the guys here is on the call, and so they'll be able to relay them to me. But if you have any questions, just pop them in the chat, and hopefully someone will just reach out to me and ping me the questions. But the main thing that you're going to be doing a ton is interacting with smart contracts, right? When you're building apps or dApps, a lot of the work that you're going to be doing, especially when you're reading data, is going to be handling requests or listening to specific function calls for different smart contracts, the kind of information that's being executed on chain. And so this is probably something you're going to be working with quite a lot. Quick swig. So there's a couple of things we actually need to look at, and I'm just going to kind of walk you through this before we have a little look at like subscriptions and writing, because this will help you understand how those interactions work a lot better, and I feel like that's going to be a lot more useful. I know that clauses was actually further over. Let's pull that up. Reading data, clauses, okay. It comes after writing, yeah. So I mean, I'm not gonna worry about that right now. Let's just stick with what we're doing. We're gonna have a look at reading from smart contracts, because, like I say, that's actually gonna be useful. I'm gonna pull that back up. So we've got our contract, which I mentioned about earlier, which is the learn to earn contract that's been compiled and deployed. And we know it's been deployed because, for a start, you have to pay for that to happen. And secondly, we know because this bytecode here is our compiled and deployed. Wait, is it? Or is the next one? Deployed bytecode. So as part of the JSON object that's returned from deploying a contract, we have the actual deployed bytecode with the constructor built in, basically, because you need the constructor data to be able to deploy your contract. Now, I've got that in this contract file, contract.js, and I've just taken the JSON, and instead of reading, like using read file or whatever, I've just made it constant and exported it so that I can access it super, super easy. You're probably not going to do it like this in real life, but this is just a demo, all right, guys? It's just a demo for you to have a look at, to understand these things and to learn, so don't judge me, all right? Then the contract load. Okay, so when you have your contract, oh, actually, we haven't finished. When you have your contract, I explained this a bit in the last one, but a contract, we get this output of a JSON object. It's a list of individual functions called our ABI. And the ABI has, you see here, we have a constructor type, we have another object, which is an event type, we have another object, and another event, another event, another event, and we've got functions, which is payable. We have, do we have anything different? We got views, so we got a view function. And each of the different functions that we've written into our smart contract all have their own little ABI objects which we can call, and in VeChain we call these clauses, and we can call each of these individual functions. Instead of having to handle a whole smart contract, we can specify specific functions, and that's really, really useful because we have the flexibility to handle these clauses, which is what I'm going to refer to them for from now on as. We have the ability to handle these, bundle them into single transactions if we want to send some assets and query something and write to a different contract. We can do those all in one transaction, and that means that building transactions is super, super flexible, which is a nice little feature that VeChain has. I'm going to leave that open because we're probably going to need it. But the way that we read this kind of data, generally speaking, is by loading up our contract in some way. Now here I've just got the ABI. So I just pull that ABI from our learn contract.abi, which I've just imported here, learn contract, and I use this SDK core package to pull this ABI contract class. Okay, and that's what's used to handle the ABI of a contract, and I've just tapped my keyboard and ruined everything. So now we're not just going to be connecting to Thor and just reading like an account or reading a transaction or anything like that. We're going to go a little bit of a layer deeper and have a look at reading smart contracts. So here we've got our app ID, which is, if you remember the smart contract we wrote for VBetaDAO, we need an app ID, and that's part of the what we got a couple of different calls. That's part of the constructor of the contract. So when we deploy the contract, we need to deploy it with that app ID, as well as two other bits of information. Our institute, do I have the contract open? No, I don't. The institute and the extra earn app contract address as well. We don't really care about that last one, but what I'm going to do is I'm going to pull the app ID from our ABI contract. I'm just going to use this get function. And what I do is, remember we were saying about which modules we use inside Thor. So we've got our Thor client set up for testnet, and then we await Thor.contracts because we're interacting with contracts, and then we use execute call. And because we're not really, like, this is used even just to query certain data, and there are a couple of different ways that you can use the contracts module to interact with smart contracts. We're going to have a look at them individually and not kind of lay it all out for you in one go, because it'll be confusing and it's unnecessary. But essentially we take our smart contract address here, and we take the function ABI, so a specific bit of the specific ABI that we want, and we do that after we've loaded our ABI contract, we use the get function method, and then we pass that as a string. So if we go, we don't have it anymore. If I just pull up our contract and chuck it up here, I think it's right at the top. Our constructor, no. Events. Okay, we'll just look at the, oh, here you go, app ID here. This, was it the one that I had selected the whole time? Thanks for letting me know, guys. So we have this view function, which means it's basically reading. It's not a writing function, and it's called app ID. And so I'm literally just calling this function, right? That's essentially what's happening here. So I'm loading up the contract. I'm giving this function, this execute call. I'm calling the app ID function with get function method. And then I'm returning the app ID.success. And I'm returning app ID.result.plain. And actually, to compare that, well, I tell you what, let's just get rid of this for now, because it's going to be, there's too much data in one go. What was it called? Contract load. Did I save it? Yes. So we'll clear this. We'll say node src contract load. Getting a little bit faster with the old QWERTY today, aren't I? Last week I was just terrible, my hands weren't working. But here I've just put some silly little console logging in, all right? But we're requesting the app ID, success is true, and the app ID is here. This is the hex encoded, because that's basically what it's going to look like on chain, and it just prints it out. Now we can actually handle that slightly differently. So for example, oh no, we can't. That's it. We got results.plain here. But what we can do, I'll put it underneath. Don't know why I didn't alt that. If we just have a little look at app ID directly as well, we can see the difference in that data. So the original kind of JSON object before I started accessing specific fields is this object with success, true or false, Boolean value. And then we got the result plain and as an array. Now, when there's just a single function being called with a single result, like app ID, the array is just going to have one element. But if you're looking at certain events, we might get a whole list of elements in our array. It really depends on the specific call. But here you can see I'm just calling .result.plain and I'm accessing it directly because I know the information that I already want to call. Okay, we'll just get rid of that. Next, we're going to get the institute. An institute is another element of the constructor. And this is basically representing like the university or the school for our learn to earn contract. So it doesn't really have anything to do with VBeta. Instead, this is more specifically to the deployment of this contract. I mean, they both are. So now if we run contract load, it'll pull our request app ID data, and then it's got the requesting institute data, and you can see the institute here as a string. It was added to the constructor as test institute, and it's doing the same thing. We're just calling a slightly different function this time called institute, which returns the institute instead of app ID, that function that we called before. And you can see any of these view functions can be called in exactly the same way. So what was this one called? Get available funds. Right, so instead we can just call get available funds, get rid of that again, and we need to go contract load here. So we're going to say, we'll just use institute, we're going to say get available funds, and instead of this, we're just going to comment that out, and we're going to console log. Alt tab only works sometimes apparently. Don't use AI, guys, all right? It's very, very, very silly. Or at least the operator is. So here, when we're returning this, we get success true, right? It worked. And here we've got plain 0n and an array of 0. So the call itself was getting the available funds, and in here it's saying that you got no funds, basically. The funds value is 0. No, that doesn't matter, it's just an example of another call that we can do. All right, and we can handle that however we like. Ultimately, we can, I know it's called institute still, sorry guys, don't worry about it. But we can essentially call any of those kinds of functions, and we don't really need to do much else to it. Now, there are things that we can do to it by adding parameters. And so now we can have a little look at a bit more of a intimidating looking execute call, because it's not just calling a balance with an empty list. This empty list, by the way, I didn't tell you here, but this is where parameters go, or options. If we have a little look here, function data and contract call options. So it's not just two things that we need to do, but I think call options is optional, yeah. If we have a look at historical data, what we're able to do is query information at a specific point in time. And we do that by querying data from a specific block, right? Obviously, because the blocks are essentially a record of time across the chain. So here we've got the VeThor contract, which I've called VeThor ABI. We're getting the balance of, and we're getting the balance of 0.0000000. Do you know what that is? We'll find out soon enough. So if we take this, we clear out of that, and we say, what was it called? Historical data. I've probably written it wrong. Oh no, it doesn't know what ABI is. Okay, well, in that case, I can't call it. Why doesn't it know what my ABI is? I haven't put it in. Definitely haven't put it in. Let's just grab it from here. So what do we need? ABI.js. Guys, I'm sorry this is missing. ABI.js. And this is the ABI for the VeThor contract. So we'll just put that in, and then we'll just save that. I know I've just done that off screen, sorry, but here it is. Because I had the terminal up. It's quite a big file, actually. I'll push this as soon as the live stream's finished. But it's basically just the ABI for the VeThor contract, right, which is the energy in our balance, and it is the gas paying token on VeChain. So if I pull this up now and try it again, hopefully it works, and it says our balance in block 1, 2, 3, 4, 5, 6, 7, 8 was 59926. And remember, oh no, I got caught in a clear loop. Is that a thing? It should be. Remember, this is actually handled. So we're dividing it by 10 to the power of 18 as well, so that we get a human readable value here as well. All right, cool. So parameters are possible. Sometimes they're specific things that need to be added. Not always, but let's just get rid of this and get rid of the terminal. But here you can see we just have this revision as part of our options, our contract call options. It's only handy if you're not pointing at it. So with our contract call options here, it's optional. Here we've put in a revision, and revision is specifically to basically take a specific block value or a block number here. Cool. We can go on and on about the kinds of options and the kind of contract calls and stuff like that that you can cover in these things, but I think we've already been here an hour, so I think it's probably time to move on. I do need another little swig of my gamer juice, and we can have a little look. Okay, so what else haven't we done? We haven't looked at realistically the next thing on the list, right? So let's pop back in here quickly. Seamless transition back to our slideshow, guys. I know, I'm good. So we've had a look at a couple of these examples, but we haven't looked at all of them. And if you have a little look at the documentation on VeChain, docs.vechain.org, there are examples and there's a lot more detail about all of these things. I'd recommend you go and check that out. You can also check out the link in the description, the Academy, VeChain Academy, which is which they have a couple of courses available for you to take to learn a little bit more about this with more examples, available source code, and they go through a lot of this information in more detail as well. So if you want something that's a little bit more guided, go to that. If you want to just tuck in, go to the docs. Well, the docs is kind of guided as well, right? If you just want to tuck in, just get in the SDK in the code base on GitHub. That's generally what I do. But anyway, let's look at code. We did that. So listening to changes. I kind of already mentioned. Basically, we're going to be subscribing to these events on the blockchain with our Thor connection. And instead of just returning one value, we're going to be returning values. We're going to establish a persistent connection, and then we're going to listen to all changes from that point, right? We're going to use WebSockets, basically. There are various different things we can do with listening to changes. We can listen to vet transfers. We can listen to transactions with filters as options. We can listen to blocks. We can listen to events. And, you know, there is probably a lot more detail you can go into if you really, really want to. But in this example, we're just going to have a look at some blocks, right? Because it's just the easiest one to look at. We get consistent data over time. It's the best experience for learning, guys. Let's just be honest. Can I just slide? Oh, I fixed the transition, fixed it. So I'm just going to get rid of all of these now because we don't really need them. We don't need transaction, return balance, contract, historical data. I'm going to leave the contract up in case we have to look at it. But we have a function down here, a module down here called subscribe. Can we get rid of that? Command B. We should probably know this, right? Command B. Nice. Dismiss. Command B. Okay, cool. Shortcut. Establish. Shortcuts are the best. So what we're doing is we're basically going to be, instead of establishing our connection with Thor client, we're going to be using our subscriptions, the subscriptions module, subscriptions dot get block subscription URL, and we're going to pass mainnet.vechain.org, because when we're pulling blocks, I mean, it doesn't matter, we can do testnet as well, but remember there's a difference here. I don't even need to go there. And the difference is there's going to be more data, there's going to be more information like on mainnet. And when you're just reading or listening to information from chain, like mainnet is going to give you better information in return. We can have a look at the other one as well. We can have a look at testnet. But essentially here, I just create a new WebSocket that connects to that subscription URL. And then if there's a problem, we error out. If it's open, we put connected, and then we just print the messages as they come. And those messages, those return messages, are just block objects. It's just JSON objects of the block. So I'm just passing that data and then using that print expanded block function, which, what was it? It was command B. And print expanded block was what made the pretty little blocks earlier. I think it comes from print expanded block. It just takes a block as an argument, organizes it in the same way that I kind of did for the other one, and then it makes a color scheme, maps the block, and then list to lines basically takes the lists and maps them together and prints out lines in the console. All right, it doesn't matter. You can have a look at it if you want. We can mess around with the color schemes. In fact, if we look at color scheme, make color scheme, you see it just grabs index 13 of the reversed list. Let's just do 5, right? And then if it's equal to 5, it changes it to 3, and if not, it just, I don't know, 5, right? We'll just keep it as 5. Okay, so now we've just got a new color scheme. It doesn't matter, but there you go. So subscribe, we're going to print out blocks according to that color scheme, and that's how we're going to kind of organize the data. It doesn't matter, it's just to change it a little bit. So we're going to go node src subscribe. Is it subscribe? Yeah. Hopefully I spelled this right. So connected with our WebSocket, obviously, command B, get rid of that. And now blocks should turn up every 10 seconds on VeChain. So by the time, there we go, by the time I finish any real sentence, especially if I'm feeling rambling, we should then get another block. Oh, excellent timing. Like, can you believe that? Honestly, like, I have no idea how much 10 seconds is, but I'm going to guesstimate it's around here. Oh, I messed that one up. Well, look, guys, it's not a perfect system, but essentially what we're doing is we're just maintaining, we're keeping that connection open. I mean, it's just a WebSocket, right? It's just a WebSocket that then returns the data of a block. It's not that fancy, it's not that interesting, but it is really, really useful in your applications, because if there's a contract address you want to track, or if there's some transaction, some asset transactions that you want to track, or if you're just tracking a certain wallet or something like that, for example, contract address or whatever, you can build this WebSocket and we can use these kind of functions. Let me just, what's the Control C? Yeah. Get out of there. We can establish this WebSocket connection through our URL. And if we have a little look, I need to go back. We can look at specific events from a contract, right? We can have a look at transactions, we can have a look at blocks, we can have a look at vet transactions, and we have these beads as well where we can look at like contract addresses and stuff like that. So this is more useful, I think, for most back-end services than just a simple kind of API call, right? Like normal read functions where you're just returning one, like it's like a one-time thing where you'd have to do it over and over again to get any kind of persistent data. And really, really useful to be able to listen and subscribe to these events. Cool. I mean, WebSockets aren't that exciting, right? You're probably already reasonably familiar with them, but now we can have a look at like the real stuff, writing data. Now, before we actually write any data, what I want to do is I want to allow you guys to do this stuff all in the back end. So no front end connection. We're just going to do everything on the back end. And in order to be able to do that, it's a little bit fiddly. So before we go through here, you can see the #1 requirement is that we have a wallet private key that will sign transactions, because when we're writing data to the chain, we're making a change to that data. And in order to do that, we need to write up the changes. We need to record them, execute them, and then record those changes onto the blockchain in the form of a transaction on the block. And there are so many things that can be involved in this, but ultimately a change requires a transaction. That's all you got to remember. So if you're writing data, you have to pay some gas fee at some level, otherwise it's not going to work. So the requirements, have your wallet. So the first thing we need to do before we even start looking at code is we need to get a wallet, right? Then we need to define clauses. So even just a vet transfer requires a clause. And we'll have a little look at that in a sec to explain it in a bit more detail. We need to calculate how much gas a transaction will cost. We need to build a transaction object with all the previous information. that we've just mentioned. And then we need to sign and send that transaction to the network to submit it to the chain. So it's included in a block. And that sounds like a lot of steps. It kind of is. It kind of is a lot of steps. But once you have it formatted and we kind of understand the processes that we need, then we'll be good. Right. Clauses, call function. We're not there yet. We're not there yet. And we kind of already had a look at clauses anyway. It doesn't even matter. It doesn't even matter. So let's have a look at some Command B. Nice. We'll get rid of subscribe. We'll get rid of our little color scheme thing. So we need to have a look at writing transactions. The first thing that we should really do is get our address. All right, I've teased that a couple of times, but I have a little function down here called wallet. Now, if you don't understand how wallets work, generally speaking, like in crypto, it doesn't matter. We're going to have a bit of a high level look at that now. But one really good thing about the SDK is that you can understand this to a bit more of a depth than you would if you just had some wallet app, you know, or like a browser extension or whatever, like vWorld, for example. Most of you, if not all of you, probably already have a wallet set up, but when we're dealing with these kinds of things, especially for the example of actually just looking at the SDK and the kind of tooling that comes for back-end services, you probably don't want to be sitting there signing transactions every time, right? You might want to be able to just execute stuff, and so this is kind of where this kind of tooling comes in. So our wallet is going to generate using SDK core, the SDK core package. We've got mnemonic, we're pulling in hex, HD key, which is hierarchical deterministic. Oh, here you go, BIP32, in case you were wondering. Basically, derived addresses. So instead of using a root address from your mnemonic, and then address, which I'm not actually using anymore for whatever reason. Probably I just didn't need to. But what I'm going to do, or what we're going to do in this function, is we're going to generate our mnemonic. So we're going to create a mnemonic, and you know what? Let's print that first. We'll just go one step at a time. Let's just go get rid of that, get rid of that, get rid of that. Actually, let's get this in. Root private key is probably good. We don't need derived addresses. We go. Oops. What have I just pressed? What have I pressed? That's some crazy shortcut. No, we don't want that. We want to be over here. Let's go all the way down here. Don't care about any of that, any of that, any of that. Okay. And what we do? Return. I could have just done it. I could have just dealt with that down here, couldn't I? It's been a long day, guys. All right. So I'm bound to make some silly little errors at some point. We'll leave that in. So what we can do here, hopefully, if things have worked all right, is run wallet, and then it will generate a mnemonic, and it will generate a root private key. So the root private key is what gets calculated from your mnemonic, basically. Mnemonic's just like a human readable version of your private key. And this is a root private key because it's used, and this mnemonic and this root private key is used to then basically calculate new wallet addresses. And this is good because it allows you to have some level, this is with the hierarchical deterministic part of it, right? BIP32 means that you can derive addresses. So you have like you can have multiple addresses from the same mnemonic, which allows you to make multiple wallets. It allows you to have multiple signing keys. It creates some level of privacy, like an extra level of privacy and security over your specific wallets. Because if you just have your mnemonic available, or if you use that root private key, then if that gets exposed for whatever reason, they can derive all of those addresses and access them. But so that's a huge problem if you're connecting to an application that might be naughty or gets hacked or whatever from your mnemonic. So instead, you use your mnemonic as a root private key to derive new addresses and new wallets, essentially, so that you can use them with apps. And it's like having, it's similar to having like what is it, like, you know, you have the disposable kind of cards with like Revolut and Monzo and stuff. It's kind of like that, right? You can derive new addresses or new cards and use them to obscure your root private key, like your actual, your main, card or whatever. That's probably a terrible example, but hopefully it makes sense. So now I'm just gonna, what do we need? We needed this one. Now we're gonna actually generate a wallet. I think we need this as well, probably. Yeah. Do we have wallet data? Oh, we're just, did we get a couple of, yeah, I'm just gonna do it all. But basically what we're gonna do, I can get rid of this, is we're gonna take a root private key, we're going to get one of these, we're gonna create our hierarchical deterministic lishness, and then we're going to derive 5 addresses. I'm only going to do 5 addresses with this for loop, right? But basically we're going to use this HD key class to derive our hierarchical deterministic addresses and private keys as well. Or we can do private keys. I'm actually going to ignore that, I think. Or not. Maybe I will include it. But basically take you through this process so you can see how it works, right? Or you have some kind of visual representation of it. Now I'm only going to put my root private key and the mnemonic in here, and I'm just going to put the derived addresses by themselves. And we're going to have our HD fingerprint here, which is just a fun bit of data I'm going to chuck in to make it more interesting, basically. We're going to put that through our colory stuff, and we're going to make it pretty in the old logs. So we'll save that, we'll pop over here, and we'll run wallet, and we'll command B it so we can actually read what's going on. So here we've got, if we scroll up, you'll see it's actually created a different mnemonic. So the root key is also different. All right. When you do this yourself, don't just show these things on the internet, obviously. Even if it is like a wallet that you're going to be using for testnet, you're still exposing private keys and stuff. And it's just generally bad practice. So let me off. It's happening here for the example, for educational purposes only. But what I want you to do is basically just generate one, and you can just kind of keep going until you find some nice color scheme that you like. And you'll say, okay, cool, we'll use this one. Once you have your wallet, we're going to grab the mnemonic, and we're only going to work from the mnemonic because we can calculate, even though we've got all these addresses here, and we've actually got a bunch of private keys stored as well if we want to use them. We don't really want to, right? For what we want to do is we want to derive these things on the fly. So, well, at least that's what we're going to do in this example. In real life, you probably just work with one of these things, right? But for argument's sake, we're going to derive these things on the fly, and we're just going to go to the same index all the time. What I mean by index is we're calculating an index of our child nodes. So we're working through this like it's a deterministic tree, right, of data. So we're going to a specific node at index whatever, and then we're using that to grab an address from that node, and we have a key as well. And so where's that then? So where's that? Well, I don't know. I'm obviously not handling it very well. It doesn't matter. But basically, we're going to use these to be able to interact with contracts, send assets, and stuff like that. And what I've done is I've got 2 in here. So I've got user 1 and student 1. We'll get onto the student bit in just a second. But basically here, user 1 is just a mnemonic that I've used. Again, guys, don't really show these things publicly, all right? I kind of have to be able to explain this stuff to you, but just hide this stuff. Excuse me. But yeah, basically I've already done this, but what I want you to do is I want you to just like replace student 1 or like create a new user and put your own mnemonic in. All right, and then what we can do is we can use that mnemonic, and you can fund it from the testnet. You can derive an address, and you can fund that specific address, and then just use that address in the rest of the code base when we're writing transactions. And that kind of helps you to experience the benefit of these HD wallets. It helps you learn to handle them and work with them as well. Even though the code's already kind of written for you, you still have some kind of reference material you can come back to, and you can see how this stuff works, because this is one of those things that's really, really heavily used in crypto that people don't really understand. Like, people understand what a block is, right? But when it comes to wallet derivation and stuff like that, it's not really something that people experience. They just use MetaMask, or in VeChain's case, VWorld, right? And they put their mnemonic in and they write it down on a bit of paper, and that's it, they've forgotten about it. But understanding why that provides this kind of level of security is quite important, I think, and it makes you have more of an in-depth knowledge about the tools that we're using. Off the old milk crate now. So back to work. Grab your mnemonic, right? So we'll just grab this one. And we're going to Command C, and then we'll get rid of that. And then we're going to go export const student2. Wait, does it already have one? Oh, no. You know, so this is another thing with AI, right? If you're using AI, it remembers these things. And I know this is just reading it from student 1, all right? I'm not that stupid. But like, there are plenty of examples of API keys leaking and stuff like that. So just be careful when you use AI for doing anything, all right? Just be careful, guys. What do I need to do? I need to get rid of these, and we'll just replace them as space bars, apparently. That's how I'm handling it. Macro would be nice right now, wouldn't it? Nailed it. So now we have a new mnemonic which we can use to derive addresses, and this represents, in our example here, a completely different student, right? It's a completely different student. But what I want you to do is just replace like student 1. I'm just tracking it so that I can, because I can, right? We don't want that. Actually, let's just clear that off. Get rid of that. What is it? Command B. Nice one, guys. I knew you'd remember. You know, I knew you'd remember for me. So the main thing now is like we need to fund this wallet. And realistically, we could derive an address and hit the faucet, but we don't really want to do that, especially for like testing purposes. What's going on? Dictionary? No, I don't need dictionary. Especially for testing purposes, what we really want to do is we just want to fund a wallet a tiny amount so that we're not, I'm just going to leave that, so that we're not like filling up wallets with like throwaway wallets, sorry, with assets, especially from like the testnet, because the testnet's for everyone to use. It's not like your own personal private testnet. And so we need to have like some level of responsibility when we're getting these assets, because there's a finite amount. So it's something to be cautious of. We can get rid of all that. We'll just put a return here actually. And what we can do here is we can fund your, like go on to VWorld now. We'll have a little look at this in a second actually, but go on to VWorld. I'm not going to show you how to set up VWorld. We'll do that in the front end workshop next week. But like go to VWorld or go to your wallet now and switch it to testnet. And then you can hit the faucet, testnet faucet, and you should just be able to like Google VeChain testnet faucet. We'll do it now. We'll do it now. But first I need to get an address. So what I'm doing here is I'm on the testnet. I'm using Thor client, trusty old Thor client. And then I'm taking, what was it, student 2. Student 2 will do, and we're going to go Alt-Tab. So we're going to grab student 2, we're going to split, so basically we're going to derive index 0 from our wallet, and we'll have a little look at like 2 or 3 of them. I know we've already seen them in the console, but we'll have a little look at them still anyway, but we'll derive child 0. Okay, and then we've got our private key. I'm obviously not going to be printing that, but we can, and then our child actually returns a private key and a public key, and we can have a look at it all actually. Console log child. Thanks for listening. So we'll print the child and we'll print the address as well. But here I'm just taking an address from a public key because there's a private and public key pairs, and just putting that into a string. The string will be hex, and so it'll look something like this, 0x33715. We'll print it out on the console, we'll see what it looks like. Did I save it? Yes, let's go here. What was it called? Write transaction. Spell it right this time. So it's hex, right? So it comes out in this uint8 array. which is basically unusable in its state, right? Most of you guys probably don't want to use things in this. We want to look at something that's human readable. Here we've got index 0, right? Depth 5 for, we've got our pub key, we've got our private key in bytes, we've got our pub key hash as well, and which is how many? 1, 2, 3, 4, 5, 6. So we've got 18, 20 bits. And then we print out our actual address, right? This is actually a useful bit of information here. But anyway, we had a little look. So it brings out all these uint8 arrays. We can obviously convert types as needed, but generally speaking, instead of just actually printing out a full child, we're just going to console log certain things that we actually need. So if we just do that, and we print the address, it should just do A1. This is the fallen, there's a fallen address. No way. That's fun. One thing, this is just a side note, guys, but when I do things like this, I often print a bunch until I get something like good. It's just RNG, isn't it? So like I'll roll the dice a bunch of times and print out some until I get something that I can refer to easily. And you know how that works. You're either looking at the last couple or the first couple, and to have like a fallen wallet, it's not really fallen because it's fooled, but fallen's good enough, right? So the fallen address. Now what we can do here is we can actually just send that some assets, right? So if we have, let's go over here, get out of this. Well, actually, if I just let's get out of this, and then we go open up vworld. Make sure we're on testnet. We are. If you're not, do we click up here for testnet? No. We click down here. We click on networks, and we select testnet. All right. So if you're doing this at home by yourself, just go on to testnet, and then we can send assets back to home. We've got our address. We're going to send, well, select token. We're going to send vet. We're going to paste it in, use that address. We're going to send 10 vet. Next, we're not going to do fee delegation. We're just going to say, pop your password in, pop the send in, and actually what I'm going to do, I'm going to send some VeThor as well, because if we're going to be using it for transactions, it's probably a good idea that it can pay for those fees, right? So we're going to command V, pay it here. We're going to add 20. Next, confirm. Right, I know that this whole bit is like, it's not really SDK stuff. It's not really back-end development, but like this just means that we can use our address in the back end without having to either use our actual mnemonic, because that would be insane to do that, especially on a live stream. Hopefully that's not what either of those mnemonics I have in user is. It's not obviously. But also then we can just derive these keys. We know that index 0 of student 2 has 10 vet and 20 VeThor, so now it can send assets and it can pay for transactions, right? So that's basically what we're doing. Now, what would actually be really good while you're there is to grab your actual address. I'm not going to do that because I think this already has an address in here for me. And alternatively, you could just derive one of the addresses for the other users, right? The other people in here. We could just grab student 1 or user 1 and then derive the address for them. In fact, shall we do that? Yes. Okay, so we know how to do this, right? We're going to have to rename these things. But if we just copy this and we say, cool, let's do the same. Let's go that way. Child 1, key 1, yeah, address 1, cool. We don't want to do it for student 2 now, do we? We're going to do user 1 instead. We're going to derive child 0, child 1 private key, child 1 public key, address, and then we're going to do the same where we console log address 1. Oh, wrong button. Oh no, it's not listening to me now. There we go. Don't get confused with the keyboard shortcuts. All right, so we're not even writing our transaction yet, but what we're going to do now is we're going to get the recipient address. So we're going to send it to the other, to user 1, all right, instead of student 2. And actually, I think I need to add them in. So we'll do that. What are we returning? Why is that? Oh, it's because I've already returned, isn't it? I wonder why it's graying everything out. Let's do Shift, Command X, paste, space, and then we'll go here, and then we'll say, well, let's just clear first. Why is this still coming up halfway? I thought I'd full screened it. Don't worry, I figured it out. Right, transaction. Okay, so now the first one we know is our student 2 address, index 0, and this is going to be user 1. So I'm going to grab that, I'm going to minimize this, and then we can actually just get rid of that entirely. I mean, we could just add it as a variable here, actually, so why? Ugh. It's been a long day, guys. It's been a long day for me. What I'm going to do is I'm just going to undo all of this stuff now. And we're going to have a look, finally, at actually sending a transaction. So we got address 1, and I'm just going to put, what's going to change it to? Address 1, smart. Do we have any interesting logs up here to tell us what's going on? No, we don't, but we don't really need it either, do we? Let's just get rid of that. So we've mentioned building clauses already, and we've looked at them for like read events, and we've looked at, well, reading from the chain, right, using specific clauses, but this time we're going to use a specific clause. I'm going to use this clause class here. The clause class allows us to do certain common clauses very easily, and in fact, this is just in the case of a transaction. Just sending vet, but we still need to do this. And I'm not going to send 10, I'm just going to send 1. So what we're going to do, in order to transfer vet, well, it's going to pop up for us. So we need a recipient address, we need an amount, and then we have some options as well. But I'm not going to worry about options or anything like that. We're going to keep it super simple. Excuse me. And we're going to transfer 1 vet. And we're going to transfer it to our recipient address, which we're going to use this address class to get. And it's address of, and we're just passing the address as a string. And let's make sure that that's coming through. Address of accepts the big int, number, string, uint, array, or hex uint. I mean, it takes everything. Like, what could possibly go wrong? This is going to work first time, guys. We're going to estimate our gas and we're going to pass our clause and our address in, because we need to know what the actual gas usage is of our transaction for us to be able to add it to our transaction. And then we're going to do this little thing called default body options. We're going to get the default body options. So essentially what this does is it just gets all the default transaction options to make our transaction body. And then we're going to append them, right, the things we actually need. And we're going to kind of fill in the gaps with our default body option, right? So we don't have to mess around with the full extent of a transaction body. And you can actually see this come up here. We're going to await Thor client.transactions, because we're going to be writing a transaction, and we're going to use the build transaction body function. And you can see here that this takes a clause for a start, or a list of clauses, and it requires a gas and it requires options, and these are transaction body options. So here we just get our default body options and then we pass them in. We calculate our total gas that we need. So actually, let's just have a little look at that. You know what, there's no point. There's no, yeah, there is a point. There's always a point. We'll get rid of this. We go up here and we'll have a little look at the gas, because there are actually different ways that we can calculate gas. This is basically like the old way of calculating gas. Now we have dynamic fees, dynamic gas. So this estimate gas is basically just going to find the original version of that, right? Like the old way of finding out the gas. And to be honest, because I haven't worked on this code in a while, I don't think I have the latest version. So my bad, guys, my bad. We're going to log this so we can have a look at the response from that. And what do we want? We want to log gas result. What does gas result look like? It's estimate gas results, but is it going to give us a thing? No, it's not. It's not going to give us any idea. So we're going to have to look at it first and then figure out how we can prettify it. Do we need to return? Course we do. And then, yes, nice and easy. So when we calculate our gas for executing that clause with our address, we haven't actually sent anything yet, but we're still logging those addresses. So I'm going to get rid of them in a second. But you can see the total gas that we need is 21,000. Okay, cool. We can handle that. We can handle that. So let's go up here. Let's get rid of these address logs because we don't need them. And actually, we don't really need this anymore either. So now I can pop that in. So we get our default body options. We will add this in. And this builds the transaction, but it doesn't actually submit it, obviously. Because in order to, but what it does is it gives us this transaction body type as our output, right? Which we can then sign and submit to the chain. Without actually signing it, we're not going to be able to submit it. And what we need, who do we need to sign? Who do you reckon? That's right, student 2. We need student 2 because user 1, this user 1 is the recipient, right? They're receiving it. Student 2 is the person we're actually going to do this with. And remember, we've sent 10 VET and 20 VeThor, so we know that they can actually handle the transaction as well, because we're only going to send 1 VET as our in our transaction. So once we built our transaction body, we need to basically use it to construct this transaction class, and it'll just make this type, this transaction type, as our output. A transaction of, right? It's very intuitively written. It's very easy to kind of understand what we're up to. We're taking our transaction body, which defines the clauses, the gas, and the default body options, and then we're turning that into an actual transaction, which we can sign. Oh, wrong button. And this is the kind of point where on a front end you would pass it to your wallet connect, like VeChain Kit, for example, where it would request that signature. But we're doing it all in the SDK, obviously. And so we're going to sign it with private key. And let's just make sure that is the right person. Where is private key? Private key here is our student 2, so that's right. And then we're going to encode the transaction once it's been signed. And we're going to prefix it with 0x because it's going to be hex. And just to make double sure, we're going to define it as a hex string. Then once we have that, we can submit it. And I kind of do, we do 2 steps in one here, because we await Thor.transactions.send raw transaction, which is actually submitting it. And what we do is we skip a step and we just wrap that in some brackets here and return ID. And that's kind of cheating. That is kind of cheating. But it's happening, all right? So get over yourselves. So basically that's what we're going to be doing. We're going to return the raw transaction submission, and then what that's going to, let's have a look. Let's have a look. I don't know why I'm just talking about these things. Equals await Thor client send transfer, blah, 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 blah. Thank you, AI. And then we're just going to alt transaction. Cool. So we're going to just separate those steps instead of me cheating and doing both in one, basically. And we're going to have a look at a receipt as well, which we didn't actually look at before when we were looking at reading data on chain. But we will have a little look at a transaction receipt. And what a transaction receipt is exactly what it says. It's just a basic receipt that tells you about the transaction. So I'm going to console log our transaction first. And then, you know what, let's, why is it done like this? Oh my, we don't want that, we want this, don't we? You know what I mean? Amateur hour, guys. Get rid of that, stick one of them in, and we're going to do the same here as well. What do we want to do? Oh, there you go. Now you know how to do it right, don't you? We're not going to return transaction ID. We're going to return the full transaction. So there's a difference between, obviously, the transaction that is returned when we submit it and the receipt itself. So we're just going to have a little look at those quickly whilst I'm talking about it. It's a very one-way conversation, sorry guys, so I'm just kind of doing what I want at this point. But hopefully it has some value for you. So we need to wait for this transaction to actually be submitted, and this is where we figure out whether or not I've done something wrong, basically. And okay, so it's worked, but I'm an idiot, and I haven't dealt with it, so now it's just returned objects. Nice. Nice, guys. Very nice. Okay, so shall we mess around with that? I mean, the fact that it's returned something and not errored means that it has worked. We think, because we haven't actually seen it, right? So we can only assume that it's worked and not necessarily that it has worked. So what we can do, instead of messing around with everything, is just say, oh, we'll just return the transaction ID. But, you know, if we have our transactions, we can, okay. All right, let's do this. Let's do this. We're going to put ID here, and we're going to change this to testnet, and then we're just going to run it again and actually pretty print something. We're going to get rid of that, and we're going to put ID in there. ID is going to be a string. We're going to handle all these things. We're going to transaction. We don't want to pass an ID, do we? We want to pass the whole transaction. Okay. So I know we're kind of doing this backwards a little bit, all right? But I'm just patching it together so that we can just put it and print it, all right? To save me from, realistically, from cluttering this up. And it is going to break things, guys. So apologies for that, but we're just going to import. We're going to import it. It knows what I want. It knows what I want. And then we're going to try it again, and hopefully this time it actually gives us some decent info. What we're going to do is we're going to get rid of that. And we're going to get rid of this. And actually, we're not going to get rid of that. We're just going to get rid of all of this. Cool. So now I should do it by here, right? Instead of just doing my thing. So what we're doing instead, basically, when we signed the transaction originally, it just returned those objects, right? But it returns objects instead of printing out the objects, which I should have just known it was going to do something stupid like that. Instead of doing what we wanted and actually just showing the information so we could compare it, I had to prefix things with titles, right? In my infinite wisdom. And so because of that, it didn't print the data. And the issue there is it also doesn't save the data because I'm running this stuff as a script, right? I'm just executing the function, right? I'm just calling write transactions down here. So I kind of screwed this up for myself. What we're doing now instead is we're pulling the transaction. We're going to log the transaction ID just by itself. And then what we're actually going to do, which I haven't implemented yet, is we're going to call find transaction and pass the transaction. Now, we don't need to do that, actually, do we? So let's just go get rid of that. And TXID we've already got. Cool. You know what? We want to have a look at the receipt. We want to have a look at the receipt. So I'm going to send the transaction, and hopefully that is actually right. That's what we need to do, isn't it? Change things. Yeah, we're going to call that on testnet. So this might take a little bit longer than first time, especially as soon as I'm establishing a connection twice and blah, 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 blah. But guys, we're just patching this together for the live stream, you know, for the workshop. So we're going to execute this. It can't read properties of ID because it doesn't know what type the transaction is. Okay, dot ID. There we go. And in fact, let's just do TX ID, right? That'll be easier. And then we got to change this to do that. All right, cool. So now it's just going to be an ID. But it's going to be called transaction, naming things. straight in. We're messing stuff up for everyone. Okay. All right, we got an error. I'm not going to mess around with it. Let's just try and run the transaction again. And apologies for messing us all about. So I'm just going to print the receipt. And up here, I'm just going to print. I don't have time to mess around with these things, basically, guys. So if it doesn't work first time, then that's it. We're getting past it quick. Yeah, we do want TX ID, don't we? All right. Let's get rid of this. And what do you mean module not found? What have I deleted? What have I deleted? Oh, basically, maybe I haven't exported the function here. Oh no, I am. I've imported it wrong. I must have. What did that error actually say? Right, transaction.js, module not found. I mean, pretty sure it's there, guys. Pretty sure we've already called it. Oh, there we go, it's working now. So obviously an importing thing. I've done the import wrong. Cool. So now we should get our transaction ID there, and then we've got our receipt. So instead of pulling our transaction, oh, I need to learn what the keyboard shortcuts are for this. So if I get rid of this, I get rid of this, and I just replace it with the actual transaction ID, we can see what the difference is. This is the ID. We can see what the difference is between a regular transaction and a transaction receipt. So we got our receipt there, and then we just say, what was that file called? Transactions. So if we have a look at transactions, oh yeah, we're going to prettyify it. But the transaction itself, when we return a transaction, it's got all the information. It's got the clauses we've executed, it's got the gas, it's got everything. What are we doing for time? Oh, blimey, we need to close it up soon. I've been rambling. But it's got lots of information here. We don't always want information. Sometimes we just want to know that something's confirmed, right? Which is what the receipt's good for. So if we have a look at our receipt, it's got the transaction type, which is useful to know. It's got the gas used, which again is useful to know. It's got our gas payer, which is our fallen address. It's got the amount paid. It's got a reward. It's got reverted false, and that's actually the key bit of information, but we'll get back to it. It's got some block data, and it's got a list of outputs. Because it's not going to a contract address, there's only one object, and then it's got the transfers in an array, which we haven't expanded. But the main bit of information that we want from our transaction receipt is this reverted value. And what reverted is actually referring to is whether or not the transaction failed. Like, has the transaction been reverted? And we don't get that information if we just query the transaction. It's not in here. So if we're looking for whether or not a transaction's failed, it's good, and I just recommend it in general, it's good practice to get a transaction receipt. Just like if you go shopping, you always want to get a receipt. You know, even if you do hustle your discount or something, you still want your receipt. And it's exactly the same here. Like, a transaction ID only has so much value. It doesn't validate whether or not the transaction is actually confirmed on chain. but getting the receipt does, and it allows you to check that. So I would always recommend, probably best practice is to be able to do that. Now we are heavily running out of time, so apologies for that, but it doesn't matter because I'm just going to open this up anyway. I'm going to carry on where we were at. So we've got a bit of a roundabout way to have a look at all this stuff, but we have had a look at writing all of this data. Now the next thing that we actually want to have a look at is clauses, and in fact we've had a look at a lot of clauses already. Let's see where this goes. Fee delegation. Okay, we're gonna have to skip fee delegation, all right guys, I'm sorry. But don't worry, fee delegation's pretty easy. And there's examples of it in the code base, in the docs, and if you go to VeChain Energy, there's probably examples there too. Cool. We're going to work with our learn to earn contract. I need to sort out the syntax highlighting, don't I? I know I do, sorry. So basically, our contract, which we've already used and has been just sat here idle by itself this whole time, for our learn to earn contract is the code that we wrote in for the last example for the Solidity workshop. And bear with me 2 seconds. Cool. So what we want to do is actually use this, right? That's kind of what we want to demonstrate throughout these examples. We don't just want to look at transferring some vet to people. We want to actually look at using this and building on this. And the whole point of these workshops is to go from basically through the whole process of deploying our app. So what we want to do is we want to write the transaction code that allows us to interact with this contract specifically. And the main thing for that is to basically register as a student. To be able to register as a student, we need to pay 1 vet, if you remember back to last week's live stream. We'll go down here, we got learn to earn here. And this learn to earn contract is for exactly what you expect, right? It's a learn to earn platform that we're using as our example here. And we need to, where is that function actually at? Add a student, right? It's a function for students to register by paying 1 vet. Now, we've already built our constructor, we've already deployed the contract. And so this realistically is a function that we can all test together. So in order for us to do that, we need to basically put a bit of data on chain that registers the wallet address as the student's name, and this, a lot of this stuff's auto added, right? Because you're initializing a new student. So it takes the signer or the sender, applies that to the wallet. We add our own arguments of our name and family name, and we pay 1 vet. You must pay 1 vet in order to register. So that's the process that we're going to go through now, and we're going to do it in the next 4 minutes on point. So obviously I've already written the code. All right, guys, I'm just going to tell you now, I've already written it. So we're going to register a student here, and I'm going to just walk through this quickly with you so that you have an idea of how it works. First thing we need to do is not be student 1. We want to load student 2. Because we've just funded that wallet, and so we might as well use it as a fresh student. We're deriving our child keys at index 0, which is the one that we use to actually fund. That's our fallen wallet. We got our private key. We're going to log the address anyway to double check. We're going to call our contract here. Now, this is the contract address that I've registered, all right, with this, which I use to deploy. So we need to use that. Wait, do we need to use that? Yes, we do. Blockchain address of the contract, exactly as I suggested. Here, we're actually going to be doing the contract itself differently. Instead of loading the ABI, we have the ABI here, but we're going to load the contract. Wait, do I? No, I just use call function. That's not even used. Okay, we're going to ignore that. But the contracts.load, that's another way of loading contract data, by the way, guys. We didn't actually cover that because we're going to use this instead. And instead of loading the whole contract, we're just going to call the function, and we're going to get the function from our ABI, like we did in the previous examples. So we're going to do the add student function. We're going to pass some information. So we're going to pass Bobby Beans. 10 vet to anyone who can put in the comments that reference. We've got our call function, we got our address, contract address, our ABI function, and we haven't actually looked at this clause class too much. We did touch on it once back here for transferring, but we haven't touched on it a lot. And what this does is it literally, here you go, represents a transaction clause. Super simple, right? Like I say, with the SDK, it's very, very intuitive. And call function is because we're using because this is a function that we're calling, an ABI function. And so we need to add the appropriate function as ABI. We need to add the contract address. I mean, it says here, the contract address, the function ABI, arguments as necessary, an amount of vet if needed, right, is an optional amount, and clause options, again, optional, and it returns a clause. And that clause, add student, we just add to our list here for our estimate gas. Again, I'm using the old school way of estimating gas. I'm sorry about that. I'm going to update the code base, all right, to have the dynamic fees. I'm such an idiot. We got our default body options. We got Thor.transactions.build transaction body, right? That's kind of familiar. We add our student clause here. We've got our gas calculation, and we've got our default body options. It's exactly the same as what we used in write transaction. And then we're going to sign with our private key, and we're going to submit it to chain. I'm bundling this again, as you can see. I'm wrapping it up, and I'm printing the receipt. We're only going to print the receipt. We don't really need the transaction ID anymore, and I've kind of explained why that's the case. All right, so we're going to register Bobby Beans. We've got his wallet here, and the private key is what we should be signing it with, and we are signing it with private key. Okay, cool. Does that make sense? I know I've whizzed through it, but I'm really, really short on time now. We're overrunning at this point. So, reminder, what's going on? We're gonna do this add student function, this clause here. And in order to do that, it's a function, it's payable, right, which means you're submitting a transaction, and it requires two inputs. Both are strings. One is the name and the other one is the family name or surname, right? I don't know why it's family name, but it is. And so what we've got here, if we compare that to our clause, our call function here, I need to get off the keys, the mouse, where our first name Bobby, surname Beans, vet of 1, which is required. Remember, we have to pay 1 vet in order to be able to register as a student. So with that being said, let's get Bobby Beans registered. Let's clear this. And what's the function called? Register student. So we're going to node src register student. QWERTY keyboards. And cool. So we got our fallen address, so we're using the right address for that student. And then we're going to wait. We're not just waiting for the receipt, right? We got to actually bundle, execute the transaction, submit it on chain, and then return the receipt. So we got a reverted false, which is good news. We've got our block ID, we got our transaction ID here. We got the origin, so the origin address. Here, our fallen address, and we got our output, and that's basically it, right? That's what it returns. I should have actually taken the time to make this a little bit more pretty, shouldn't I? But never mind. I should do that for the receipts. I'll probably add that to the code too. So now we got Bobby Beans. Like, what we actually need to do is get students, right? So that we can return that value. And I know we're overrunning, guys. I'm just going to have a little look at this quickly for us, so that we can check this out. And hopefully you've been able to do this yourself as well, because this is all the kind of stuff that we can execute. So I hope you've managed to get your student funded, and you with your 0 index child key. And then you've used that to register your student. Don't call him Bobby Beans. All right, guys, don't call him Bobby Beans. Do him yourself with a different name. What we're going to do is get student. So get student is another function that we haven't really looked at because I've taken too long to get through this stuff. But what we're going to do is we're going to return student2, and we're going to alt return student2. And this is basically the same kind of setup for our transaction, right? We're getting on testnet, we're connecting to testnet, we're getting our contract ABI, and then we're deriving our child key for our student2 wallet. Obviously, that you wouldn't be doing this like yourself. Like, this is just a backend service kind of tool. We're using execute call this time, and if you remember, execute call takes our contract address, our function ABI, and any arguments. And the argument for students, which is our like get function, I think. Command F, students. Our students call here, it requires an address, and it outputs our student data, basically. So it grabs the student if that student's there. So that's basically what we're doing. So in getStudent, we need to pass the student address as the function argument, right? Or the, what's it called? Function data. That's it. And then we're just going to log results plain. All right. And hopefully that will actually just return our student. So we'll clear this, and then we'll go get student, which is node src get student.js. And here he is. So Bobby Beans in the flesh. So with our student struct that's stored on chain, we've got our student's address, we've got name, surname, are they registered, have they graduated, which is this, oh, I missed. Are they registered? True, we have registered. Are they graduated? False, we haven't graduated, we haven't submitted anything. And it's got a proof here, which is just initialized as a 0 value, right? It's a 0 hex string, because there hasn't been any proof provided of a submission for you to then get graded on. We're going to have a little look at all of those things in a lot more detail over the next couple of weeks when we start building out a front end for these kinds of interactions for this smart contract, for this learn-to-earn platform. And in the next workshop, we're actually going to be having a look at front-end development specifically for connecting to chain. You know, we're going to look at vWorld, we're going to look at VeChain Kit, and we're going to look at having a front end and interacting with the blockchain using that. So, clauses. We've touched on clauses a bit. Actually, you know what we've done? We've interacted with clauses in a read-only way and a write way. Write with a W, obviously. So we've actually done pretty well by that, and we've looked at simple transfers of VET tokens as well, using the transfer VET clause or VET transfer clause, and we've also looked at interacting with our own smart contract using our clauses too. So I think we've actually done pretty well. Let's have a look. We've looked at some code. We don't have time for fee delegation. All right, guys, I'm sorry about that. But basically, what I haven't touched on, the fee delegation part, is that VeChain, you don't need to pay transaction fees yourself. You can delegate your fee to a source, and you can be a gas payer, or you can set one up for yourself. The easiest way to do it is with VeChain Energy, and that's actually what's used in this example. VeChain Energy allows you to register as like a testnet or mainnet service provider, and then you just send your Vethor there, and then other people, like your users for your app, can use that link to pay for transaction fees themselves, so that they can come into VeChain, they can use your app without actually needing to have assets themselves, right? So you're thinking like non-crypto natives, right? Which is kind of what we talked about earlier when I was mentioning the kinds of people that we're marketing to with VBeta apps, with that platform. But all we're doing is we're building a transaction, right, with our build transaction body. And then instead of having our, if we just look at this quickly, instead of having our default body options, we've got this object with is delegated true. And this is just one of the fields, right? But it's kind of the only one we need for this delegation. And then we provide an internal base wallet, and we point that to sign the transaction. And then we point the fee payment service here, our gas payer, to the URL of our fee delegation URL, basically. There's quite a little bit that goes into setting this up. And yeah, so it's nice that we've actually just had this code here, even without nice syntax highlighting, just to have a look at that stuff. But yeah, then you just submit a transaction as normal, basically. Okay, takeaways. We've overrun a bit, and I'm sorry for that. But in this workshop, we've looked at what the SDK is good for, and just to remind you, the SDK is good for handling things on the blockchain in an automated way, right? In ways that where you want to do multiple actions that don't require, or that you want to abstract away from you having to sit there interacting with a web app. So if you're building back-end services, if you're building APIs for any kind of tool that you want other people to either hit by themselves and you want to stay separate, or you want to build a service that allows certain actions to take place, even if you're not interacting with the chain in a right way, you're not writing transactions to the chain, you're just tracking wallets or tracking different assets or contracts or anything, like that's the kind of thing that the SDK is really, really good for. We've had a look at reading, writing, and listening, although we did it in a different order. We did reading, listening, and writing. We actually did a ton of reading and writing and hardly any listening. Listening's the boring one, all right, guys, so don't judge me on that. We had a look at clauses. We had a look at a basic vet transfer clause, and we also had a look at interacting with our smart contract that we wrote in the last workshop, or that we went through in the last workshop, and we looked at reading from that contract with our get student, and we also had a look at writing by registering a student or adding a student. And then we spent about 2.5 minutes just now touching on fee delegation. But I'm kind of gutted about this because fee delegation is like a really, really powerful tool, and it is one of those things that's like missing on a lot of chains that really, VeChain really does super, super well. It makes the onboarding process for people who aren't familiar with crypto so nice. But anyway, we did a ton of SDK walkthroughs. We did some VeChain specific tooling stuff, and again, it's right in the middle, and I'm sorry guys, we barely touched on fee delegation, but we didn't have an example. Cool, so just to round up, the hackathon is starting in a couple of weeks. Well, it's like a month, or just over a month. The 22nd of September is kicking off, and it's closing. The final submissions are the 6th of October. There are 3 different tracks. We're offering 30K in either USD or VET, depending on the individuals. And it actually, one thing that probably should be mentioned as a bit of a disclaimer is we need to do some level of KYC in order to be able to distribute those prizes. Just a heads up on that, because that is quite important that I share that, I think. For more information, you can go to academy.vechain.org/hackathon. And actually what you really, really should do is connect with us at VeChain Builders on X and on Telegram. You can do that by scanning either of these QR codes. And I probably won't leave this up for very long, but you can just pause it, pause it as a video. Silly old sausage. And the last thing is, if you came and you did this workshop, you can get this POP certificate, again, by just pausing and scanning the QR code now. Just as a proof of participation in the hackathon workshops. All right, that's it, guys. Thanks for joining. Thanks for sticking around. I'm sorry I couldn't get any questions up because I just haven't been able to get onto it. But I hope this has been helpful. If you do have any questions, put them in the comments, and I'll try and keep an eye on them. I'll have a little look tomorrow because it's getting quite late where I'm at. That's about it. The GitHub repo where you can get all this code is in the description below. If you have any questions or comments, the best place to go is to either the comment section right here, or go and join us on VeChain Builders or the VeChain Discord, or hit me up on X, or it's at Stoic VeChain. And yeah, let's figure out how to get this stuff done. Let's build some cool stuff. That's it. All right. I mean, I don't really have anything else. Oh, I can go like that. Yeah, guys, thanks for joining. And next week we're going to be looking at front end stuff. I'm pretty sure I've already mentioned this, but we're going to be having a look at VWorld, VeChain Kit, and we're going to have a look at integrating the blockchain into a front end. So you have an actual web app that you can interact with that relays information, reads, writes, and listens to the blockchain from a web app.